Hey guys, this is Genesis, and today we're going to talk about nonlinear functions and their graphing patterns. One nonlinear function that I'm going to start with is the square function. It's also called a quadratic function, and the graph of a quadratic function is a graph of a parabola that's looking like this, like a smiley face. Okay, and before we start, what you need to know about quadratic functions is its formula. So the formula looks like this: f of x, or f at x, or f located at x, is equal to a x. You have to memorize this, so please memorize them. This. So that's what the formula looks like: a times x minus h all squared plus k. And what I like to do when I have the f of x down is change f of x into y. Now, as you may have known, this formula is the standard equation, or what I like to call it the a vertex equation. So before you can find a graphing pattern or graph a square function, you have to put it in this vertex equation of the quadratic function or formula. And the reason why we're doing that is because it's a quick and easy way to find the vertex. So, and how, but the thing is, how do we get to the vertex? The vertex would be the point where we started. V equals to H and K, right? And this case here, we see that HK is 0. What we're doing is we're in order to get to the vertex, we take out the x minus h like this and make it equal to 0. Then we're going to solve for x, right? So that means we're going to isolate x by getting h out of there, adding x to both sides, because of what you do to one side is what you do to the other side. H, negative h and plus positive h cross out, and you're left with x is equal to h, right? The k is not connected to anything, so no, you would just pull the k down into the vertex. So it will be hk. Hk will be equal to, it goes over there. H is going to be equal to h, and this is going to be k. Okay? And in this case, if we do the same thing, we have x squared, right? Just pull the x out, set it equal to 0. That's h. Our vertex is h, is 0. And k, nothing exists, so there we go. The vertex starts off with the coordinate points 0, 0. Okay? Now, how do we graph it? How do we graph this thing? Well, we can graph this function here by what we call plotting points. And notice I have y on top and x on the bottom. I do it so in other books they will put the x on top and y on the bottom. You see where I'm going here when I do it this way, because there's going to be a pattern in and when you plot the points. This function here, f of x equals to x squared, is also called the starting function or the base function. So when you're graphing functions, you always think about the starting function or the base function, and what I like to do is combine them with patterns. And let's first try to plot the points of a square function. When we look at x, when we make x equal to 0, right, y will be equal to 0 squared will be equal to 0. When x is negative 2, right, negative 2 squared will be equal to positive 4. When y is negative 1, when x is equal to negative 1, y is 1, it will come out positive 1. When x is equal to 1, 1 squared will be equal to positive 1. When x is equal to positive 2, right, positive 2 squared will equal to 4. And so if you look at this, it's going to be a pattern. we start off with the vertex. Our vertex was 0, 0, the coordinate point 0, 0. Right? Let's say our coordinate point was 0 and 0. So we start here, and notice, if you notice here, when x is equal to 1, you go up once, right? When x is equal to 2, you go up 4 times. Same thing as you go to the left side. 1, 1, 2, 2. So what's happening here is you're going over once and going up once. You're going over twice and you're going up twice. So this pattern, in order to graph the quadratic function, we're going to follow the pattern of plotting your points. Go over once, go up once. Go over twice, go up 4 times, right? So, like I said before, in order to graph the quadratic formula, follow the pattern of the base function, which is the starting point before all the numbers are shifted over, by adding a number to h or a number to k, right? And wherever you are on the graph, you will always go left and right, by a number, and up by the square of that number. Okay, so let's look at this. Let's look at the starting function. Will always look like this. You go over once, you go up once. You go over twice, you go up 4 times. And then you can graph it by going like this. The parabola will always take the form of this shape, right? If it wasn't factored by another number. So what happens if we add 3 to it, negative 3 to it? Negative 3 squared would be 9. Positive 3 squared would be 9. Same thing. This time we're going over 3 times. 1, 2, 3. 3 squared is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we can still connect the dots like this. And that's how you will always graph a quadratic equation. Now let's look at our graph paper. We're going to try to graph other types of quadratic equations. And I'm going to take my pen out here. Okay. And we're going to graph let's just graph this. Y equals to x squared. Okay, something. Notice that there is an invisible 1 here in front of the x squared. It will always be there by default. And it's not shifted. When we graph it, just like before, first we find our vertex. X is equal to 0, right? Take it out. So our k, there's no k, that's 0. That's our vertex, right? But let's say, that's going to be a vertex. But let's say we have, there's an invisible 1. X is equal to, x plus 1, sure, x plus 1, all squared, minus 3. Remember, we're going to take out x plus 1, the argument inside it, set it equal to 0, solve for x will be equal to negative 1. That's going to be our h. Okay, that's going to be our h. Our h is negative 1. Our k, negative 3 is not connected to anything, so just pull it down. Negative 3. That's where we're going to start. So we go over 1 and down negative 3. 1, 2, 3. So what's happening here is that we're shifting to the left once and then going down 3, right? Remember, when we add to x, we go to the left, right? Some people look at this and shift it out in their minds, but I don't. I suggest that, if you're a beginner, take out the argument inside the x squared, set it, make it equal to 0, solve for x is equal to 1. Okay, that's our vertex. That's our x side of our vertex, or h side, and then you look for k. K is usually not connected to a k is not connected to a variable like this one. It's just all alone by itself, and it's outside the argument, outside the function, right? Well. And then it's not connected to anything. You pull it down, it becomes negative. So you start there, and remember, we have a pattern. Remember our pattern? It will always be the same for any function wherever you are in the graph. You go over left and right once, go up once. Go over left and right twice, 1, 2, go up. 2 squared is 4. Go up 4 times. 1, 2, 3, 4. Go over. If you go over 3, if you go across 3 times, 1, 2, 3, 3 squared. 3 squared is 3 squared is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? It will have the same pattern no matter where you are on the graph. So let's look at this. We started off with this function here. We got our vertex. Okay, we're here. That's our starting point. So we do exactly the same thing. We go over once, we go up once. That's where we start here. We go over here, we go over here. Once, we go over here. We go over twice, 1, 2. We go up 4 times, 1, 2, 3, 4. We go over twice, 1, 2. We go up 4 times, 1, 2, 3, 4. Right? Let's keep going. We can go over 3 times, same thing. 1, 2, 3. You go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Same thing with the left side. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we can just draw a curve, and we're done. Well, how about this one? We want to graph y oops, sorry about that. We want to graph y equals to x plus 2 squared plus 1. Okay, we draw a graph here, draw another line here. We take out the vertex. X is equal to x plus 2 is equal to 0. Solve for x. X is equal to negative 2. That's going to be our h. Vertex is h is negative 2. K is going to be, is not connected to anything, so you pull down the k, go to 1. So that's where we start. 1, 2, right? And 1. Negative 2, 1. Do the same thing. 1 here, 1 here. 1, 2, 2 squared, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. Okay? And connect the dots. All you need are 4 points. Now, the next one is a little bit tricky here. Instead of shifting over, what's going to happen is that we're going to a 2 is going to be placed in front of the x squared, right? And what's happening here with a 2, in order to graph this function, we will follow the same pattern as our basic function. Go over 1, go up 1. Go over twice, go up 4. Go up 3 times, go up 9. We'll follow the same pattern, the basic function, right? Starting with y equals to x squared. But the difference is, since there's a 2 in front of the x squared, we need to multiply the pattern by 2. So we're going to go right or left, right? Let's look at the right side. We're going to go right once, and then up once times 2. Okay? And then, or left over once, and then up once times 2. Do the same thing. Right twice, up 4 times. So just remember, it's 2 squared. Up 4 times 2. Okay? Same thing with the left side. So let's try to graph this function. Let's make it small on here. Draw easy here. Y equals to 2x squared. First thing we're going to do is take out the x, right? Take out the x. Solve for, make it equal to, set it equal to 0. Okay, our vertex is 0. There's nothing there. This is our k. So look, here we go. Go over once. Start here with a vertex. Go over once. Go up once times 2. So we're going up 1 times 2 is 2. So 1, 2. Go over to do the other side. Go over once, go up once, times 2. So 1 times 2 is 2. Now go over twice, 1, 2. Right? Now we're going to go up 2 squared. 2 squared is 4. 4 times 2 is 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, same thing with the left side. Go over twice, 1, 2. When x is 2, 2 squared is 4. 4 times 2 is 8. So go over twice, 1, 2. And 1, 2, 3, 4, 5, 6, 7, 8, right? Then we're going to connect the dots like this. Okay? So that's how you graph a function where you have a factor of 2 in front of it. Now, what's happening here when you're graphing with a factor of 2 in front of it? Get rid of this. What's happening here is that you're stretching the graph or expanding the graph. It's getting faster and faster. So let's say you have this. This is your starting function in here. Let's look at. We're just looking at the quadrant 1 side of that of a quad function. But we're going to ignore it. So I'm not going to draw the other half side of it. Just this side. Let's imagine that when we're graphing a quadratic function, imagine it's like the U.S. economy, right? Or the U.S. market. I dropped something. Sorry about that. When the economy, when the economy is expanding, right? It gets faster and faster. It grows stronger and stronger. So you are in a state of expansion, right? I always get confused with the term. So when a book talks about an expanding function, right? When you're stretching a graph or expanding it, you're going like this. When a graph is compressing, it's going to be going like this. And what happens is like the economy is getting slower and slower. But this is just normal growth. That's faster growth, and so this is stretching, and this one is compressing. Right? And that's what's happening. So this will be equal to, for example, y equals to x squared. This one will be equal to y equals to 2. What we just did, 2x squared. And this one would be y equals to 1/2 x squared. And the reason why this one is 2x squared, the reason why it's called stretching is because 2 is more than 1. Remember, there's always an invisible 1 in front of x squared. So 2 is more than 1, so it's growing faster. Here, it's vertical compression or contraction because 1/2 is less than 1. So we graphed an easy one. How about a harder one? Y equals to 2x minus 1 squared minus 5. And look, we do the same thing as before. First, we need to find the vertex. So we see this, we take it out. Oops. X will be equal to 1, set it equal to 0. Solve for x equals to 0. That's going to be our h. Okay, so our vertex is, I'm sorry, x minus 1 plus 0. Solve for x. Cross that x out. X will be equal to positive 1. That's going to be our h. Our k is going to be 5, negative 5. So our vertex hk is equal to positive 1 and negative 5. So that's where we start. Let's draw this graph. Look at where we start. We start off at 1, right? 1, and we're going up, we're going down, negative 5. 1, 2, 3, 4, 5. This is where our vertex starts. And then we're going to do the same thing as before. We're going to use our graphing pattern to solve this problem. But look, we have a 2 in front of it. We have to multiply the graphing pattern by 2. If there was a 3, it would be 3. So we're going to go right 1, once was 1 squared. 1 squared is 1 times 2, right? So 1 times 2 is 2. What 1, 1, 2. There you are, right there. Same thing with left side. Go left once. 1 squared is 1. Go up 2. 1 times 2 is 2. 1, 2. Go over twice. 1, 2. 2 squared is 4. We're going up 4. 4 times 2 is 8. 1, 2, 3, 4, 5, 6, 7, 8. Go left once. Left once twice. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8. And then connect the dots. Okay, and that's how you graph expanding functions that have been not only shifted left or right, but also has a factor of 2 or 4 of it. Now let's look at other types of functions. Another type of function that you will see are cube functions. Okay? Cube function. Let's move this up there. Put that back here. Now with cubic functions, there's also a pattern to it, right? Let me put something here so you won't block it. There's also a pattern to cubic functions. Okay, first we can plot points to find the pattern. We see that if we put 0 in x, right, y will come out as 0. Okay. And if we put -1 in x, y will come out -1 times -1 times -1, -1. We put in -2 in x, y will come out as -8. Right? We put in, oops, I made a mistake. Let me take my red pen here and fix this. Oh, you can't find my red pen? Maybe? Here we go. -2 in here will have -2. Right? I mean -8. Whoops. Whoop. We have, we put -3 in here. We're going to have -27. Same thing with this one. Part of 2, 8. 1. Wait, make this 1. Make this 1. Make this 1. 1. 2, 8. 3, 27. I like to make the colors match. 27, 3. And look at the pattern. We're going across once. Here on the right side, we're going up once. Here on the left side, we're going down once. And we're going across twice. Here on the right side, we're going up 8. And on the left side, down 8. 1, 2, 3. On each side, negative here. On the right side, we're going up 27. On the left side, we're going down 27. It follows this pattern right here, looking like this. So you're going over once, and on the right side, up once, and the left side, down once. Across twice, up 8, down 8. And it follows the same pattern every single time. Or across 3 times, up 27, down 27. But you only need 4 points, so you can ignore the third time. Unless you want to, play around with it or have fun with it. But you can just go over once, go up once, or down once, and then go over twice, go up and down 8 times. Right? Remember, wherever you are on the graph, you will always follow the pattern, this cubic function pattern. And this should let you know a cubic function looks just like an S, like a snake, right? When you're going across. Okay, so let's try to graph a cubic function. Okay. We're going to graph y equals to x plus 3 cubed plus 24. Okay, the first thing we need to do is take out x plus 3, set equal to 0. X will be equal to -3. So our vertex is -3. Grab this. It's not connected to anything. We grab that, put that inside. That's where we're going to start. So we got to draw it. Our vertex is 1, 2, 3. 1, 2, 3, 1, 2. So we start here, -3 and 2. And remember, our pattern, we're going to go 1, 1, 1, 2, 1, 2, 1, and 8. Okay? So go over once, go up once. Go over once, go down once. Go over twice, go up 8. 1, 2, 3, 4, 5, 6, 7, 8. Go over twice, go down 8. 1, 2, 3, 4, 5, 6, 7, 8. And we're just going to connect the dots from here to our vertex, all the way up there. Looks like almost like an S. And that's how you graph that. Now there's another function that we have to learn how to graph. It's called the square function. Okay? And the square root function. The square root function, and square root function is special. If you take the square root of y equals the square root of x, right? What we don't want any negative numbers in here, because a negative inside a square root, like -1, is equal to I, an imaginary number. Right? We don't want that. We don't want negative numbers. We don't want imaginary numbers inside it. We only need positive numbers that are easy, that are called integers, that are easy to graph. We don't want 1/2 inside it, because it's hard to plot the point of that. We just want something easy. For example, 2, let's say y equals to square root of 2. That's hard to graph, because that's equal to 1.41 something 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 something. It's too hard to graph. How about something easier, like y equals the square root of 4? The square root of 4 is 2, right? That's easy. How about another one is 81. Square root of 81 equals a 9. Yeah, another one is the square root of 9 equals to 3. So we have, let's find easy ones. So the square root of 0, let's do this one. The square root of 0, let's say x is equal to 0. The square root of 0 is 0. The square root of 1, that's very easy, is equal to 1. Then this is the negative side. Remember, we're not doing negative numbers, so we can immediately cross the left side out of the graph. We're only doing positive numbers. The square root of 1 is 1, right? I'll make that green for you. The square root of 1 is 1. The square root of 2, we want something easier. So the square root of 4 is 2. And another one, the square root of 9 is 3. Right? So we have a pattern here. We have right 1, up 1, right 4, up 2, right 9, up 3, like this. We're going right 1, up 1, right 4, up 2, right 9, up 3. And then when we graph it, it's going to look like an arm stretching this way. Okay, so let's try an example of this. So let's take the square root, y equals to the square root of x minus 2 plus 1. Remember, the first thing we have to do is take this out, set it equal to 0. So our vertex is going to be, well, got to solve for x, plus 2, right? That crosses out. X will be equal to plus 2. So our vertex is equal to 2 as our h, and our k is going to be positive 1. And when we graph this baby, we automatically should think, when we're graphing square root functions, we should automatically think of our pattern 1, 1, 4, 2, 9, 3. Okay? So we start at the vertex, which is 2, 2 and 1, vertex 2, 1. So we go 1, 2, up 1. That's our vertex right there. 2, 1. Now, remember our pattern 1, 1, right? Square root of 4 is 1, 2, 104, 1, 2, 3, 4, up 2, 1, 2. And let's just do another one. 9, the square root of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. The square root of 9 is 3. 1, 2, 3. Then we just connect the dots. Okay? And that's how easy it is. Now, something that's important to know, when you're graphing functions, let's say there is a negative in front of the function. Example. Let's go back to our square root one. Let's say we have y equals to negative x squared. If there's a negative in front of the x, it's not going to be facing this way. It's going to flip this way. It's just going to flip downwards like that. So this one will be, the origin is the vertex is 0, 0, by the way. We start here. Instead of going up this way, we're going to go this way and then down once. And then twice, 1, 2, 3, 4, down 4. Then twice, 1, 2, 3, 4, right? Connect the dots here, facing downwards. The same thing with y equals to x cubed. Remember, it looks like a snake that way. Well, let's say it's y equals to negative x cubed. If it's y equals to negative x cubed, instead of facing this way, what's going to happen? This arm over here will point in that way, and this arm over here will point that way. It's almost as though they're switching arms. So this would be like this. You remember our pattern for cubes? You go over once, like this, once, and then up once. You go over twice, you go up 8 times. Left side, once, down once. Twice, go over twice, down 8 times. Right? But this time where it's negative, so it's going to be the opposite way. So we're going to go over once and go up once. Go over twice, go up 1, 2, 3, 4, 5, 6, 7, 8. Go over once, go down once. Go over twice, go 1, 2, 3, 4, 5, 6, 7, 8. And when you graph a function, or when you read a function, you always read from left to right. So we're going to draw from left to right. Draw, connect the dots like this. Here. Good. And that was our vertex of 0, 0. Okay, that was just a side. Now, we have other functions to look at, such as the absolute value function. Put that right there. And the absolute value function is special because we have the bars to the left and to the right of the x. And the graph of the function basically looks like a V. Okay. Let's plot the points to find out the pattern. We have 0. When x is equal to 0, y is equal to 0. The absolute power of 0 is 0. The absolute power of 1 is 1. The absolute power of negative 1 is 1. Right? The absolute power of 2 is going to be 2. The absolute power of 3 is going to be 3. The absolute power of negative 2 is going to be 2. The absolute power of negative 3 is going to be 3. So there's a pattern here. Whenever we go over one unit, we go up 1 unit. If we go over 2 units, we go up 2 units. If we go up over 3 units, whether it's negative or positive, we will go up the same amount of units. So absolute value functions are very easy to graph. We just look at the pattern. We follow the pattern. Remember, go over once, up once. Go over twice, go up twice. Go over 3 times, go up 3 times. And remember, it doesn't, wherever you are on the graph, whether it's a quadratic function, and in this case, it's an absolute value function, we just follow this pattern. We find out where the vertex is and follow the pattern of this basic function, a starting function of the absolute value. And so let's try to do it. We're going to graph it. Okay, let's graph it. So, take a green pen here. Let's say we have the square root, y equals to the square root of x minus 2. Oops, I'm sorry guys, wrong one. Y equals to the square root, the absolute power of x plus 2. Let's graph it. Okay. Take out x, set it equal to 0. X will be equal to 0. That's going to be our h. So our vertex is 0. Bring down the 2. It's not connected to anything. It's by itself. Positive 2. It doesn't change. So our vertex is 0 and positive 2. Right? That's where we start. Right here. 0, positive 2. And remember our pattern. Go over once, go up once. Go over twice, go up the same amount of times. Go over once, go up once. Go over twice, go over once, go over once on the other side. Go over twice, go up twice. Go on the left side, go the same thing. Okay? And look, just keep going. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. We can do that forever. So we just connect the dots. Okay, and we're done. How about this one? Y equals to 3 absolute power x plus 1 plus 2. Okay, let's graph it. Take out the x plus 1. Set it equal to 0. Solve for x. That crosses out. X is going to be equal to negative 1. So this is going to be our h. Our vertex is going to be, start with h, k. Our h is negative 1. And look, our k, 2 is not connected to any variable. It's just going to pull it out and drag it down. Okay. That's where our vertex starts. Let's go there. I kind of drew this lopsided, so I'll make it on this line. Negative 1, 1, 2. That's our vertex. Okay. And look, don't forget this, we have a 3 here in front of the whole thing. So we're gonna, whatever we multiply, we're gonna multiply whatever we get, wherever direction we're gonna go. When we go up, we're gonna multiply by 3. So we go over once, and then we go up once, times 3. So 1 times 3 is 1, 2, 3. Same with the other side. Go over once, go up once, times 3. So 1 times 3 is 3. 1, 2, 3. Go over twice, 1, 2. Go up twice. Before we go twice, we multiply 2 times 3, 6. So 1, 2, 3, 4, 5, 6. Go over twice, 1, 2, 2 times 6 is, and go up twice. 2 times 6, 2 times 3 is 6. 1, 2, 3, 4, 5, 6. And we connect the dots. Hey. It will go up forever. Now, let's say a negative was in front of this thing. It will be negative 3. Right, negative 3. We'll do the same thing, but go down. We find our vertex, right? Our vertex is here. And we go over once. And then down 1 times 3. 1, 2, 3. Right? Yeah. 1, 2, 3. Right? Same thing with this one. 1, 2, 3. We go over twice. 1, 2. And 2 times negative 6 is, 2 times negative 3 is negative 6. 1, 2, 3, 4, 5, 6, somewhere down there. Other side, same thing, symmetrical. And you would just, so it will be facing downwards, okay? And that's how you graph absolute power. And there's another thing. I think it's over here. It's called a reciprocal function. And the type of reciprocal function I'm going to deal with are the simple rational functions, or simple reciprocal functions, where there are no variables on top like a or x, but just a 1. A 1 is on top. And you don't need to plot point. For reciprocal functions, we don't need to plot points in order to graph it. So we're gonna just cross this thing out, right? And when we're dealing with reciprocal functions, we're going to be guided by something called asymptotes. Okay, that's how it's spelled. And asymptotes are these invisible dots on the graph that go horizontal and vertical. Right now, it's beyond the scope of this presentation, so this is all I can tell you. What these asymptotes are, they're just invisible dots, and when you're graphing it, the graph follows the dots, right? But they don't actually touch it. So the graph of this function y equals to 1 over x looks like this. That's x-axis. That's the y-axis. It generally looks like something like this. Okay, that's something you have to remember. And what we're doing with this, how do we get the asymptotes? What we're doing is taking same thing again. We're taking x, setting equal to 0, right? And there's no y here, so y is also equal to 0. The vertex is going to be 0, 0. And what you're doing when you're graphing it, and you're starting from the vertex, and your invisible dots will go up and down, and then left. You start from the vertex again, go horizontal, left and right. And then you follow those dots, but don't actually touch them, and make a little face, smiley face, and left smiley face, and this smiley face. So let's try to graph. Let's try to graph one. They're a little bit easier to plot than the other ones, but we don't really care exactly where they are. So let's say we have y equals to this reciprocal function, 1 over x plus 3 plus 2. Okay? We do the same thing here. Going to take this out, set it equal to 0. Solve for x. X will be equal to -3. Okay? And y looks right here. So our vertex is -3 and 2. All right? Let's draw it. Okay. Starting off with here. So we're starting off with our base function, which is this, y equals to 1 over x. Okay. And what's happening here is it's being shifted over. In this case, it's shifted over 3 times. Shifted to the left 3 times. Right. One thing to remember is when you add to x, you go left, right? And in this case, we are indeed adding to s, we go left. If it were like this, y equals to 1 over x minus 3, we're going to go to the right. Look at this. We got this, and we went here. So we're going to go left. 1, 2, 3. That's where our vertex are, and we're going to go up twice. 1, 2. So our vertex is here. -3, 2. Okay. And remember, our pattern is put the dots going up and down. That's a pattern of the dots. And start at the vertex again and go left, left, and right. Whoop. Okay. And we just draw around it, but don't actually touch these invisible dots called asymptotes. Start here, the same thing. Okay. Don't actually touch it. Okay. And if there was a negative in front of it, right, it will look like this. Find the vertex. The vertex is 1, 2, 3, 1, 2. Right, vertex. 3, 1, 2. And we want to graph this y equals to 1 over negative x, but negative x plus 3. Right? And because it's negative, this is going to flip like that. So our visible asymptotes, and it's going to flip like this. Oh, I should have graphed from left to right, but this is also correct. And that, my friends, is how you graph some nonlinear functions that are, yeah, that's how you basically graph nonlinear functions. And these are the patterns that you can memorize that help you graph them. So I hope this helps you. Take care. There are other difficult functions that you will learn later. Well, take care. Goodbye.